To all of you who have just downloaded KiCad, or maybe you've downloaded it before but you opened it back up and felt like it was just a little bit more daunting than you remember, I wanted to make a video just kind of going over, just rambling off my head, the tips and tricks and menu items and explanations around a KiCad project. We're going to start with what you need to know about setting up a project and a schematic, and then we'll move into the design of your schematic, and then we'll move into your layout. We'll talk about how the layout editor works, basic hotkeys and stuff that you might need to know. By the end of it, what I want you to have is a general sense that you can open up KiCad, not feel terrified of all the options going on, and generally know how to think about and go through a KiCad PCB project. So yeah, let's get started. I have opened up KiCad here and moved myself down to the bottom corner. So we're opening up a project. This is what it looks like when you open up a project, but you can also just as well make a new project with your buttons. Now you'll notice that there's going to be at least two files that you're going to have right away. One of them is going to be your schematic, and one of them is going to be your PCB file, and they're going to be very linked. It's worth noting that I think the only thing that's required to link them is that they have the same name. So blah 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 dot KiCad schematic or SCH, or blah 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 dot KiCad PCB. And let's just jump into a schematic. Now this is a demo that I've given to the Discord community of Every Flavor Robotics as a little design challenge. If you're watching this in the future, I hope you consider stopping by the Discord to participate in our design challenges, and I hope that we are still running them. If you're watching this video in the past, I don't know how you've done that because I haven't made it yet. And if you're watching this video during the competition, then this is all stuff that will be extremely relevant. Okay, so we have a couple things here. We have symbols, we have green lines between the symbols, and we have little blue X's and text boxes and all that stuff. And you know, if you haven't figured out that if you can drag them and move them, you might want to read up on how basic computer programs work. No, I'm just kidding. It's okay. It's okay. Wherever we're meeting everyone where they're at. Okay, you can pick things and move them. KiCad has full image support, so if you want to screenshot stuff off of your computer and then paste it into the KiCad schematic, you can do that. I honestly think this is an underused feature. I think that more schematics should have a few more pictures. You shouldn't be like throwing pictures around everywhere, but sometimes it helps, you know, especially like I put this one in here to remind you all that, hey, this symbol looks really weird, but it's just a button. Okay, now let's talk about the number one thing that you're probably going to want to do in a schematic, which is adding more things. Now you can remember this really easily because add starts with A. So if you press A, it will add a component, and you can type in anything that you want. Let's add a resistor, okay? I like to use the US because I was taught that resistors are a little zigzag, and I specifically like to use the R small US just because I feel like my schematics get really messy and jumbled up. So anyways, whatever you do, you can use a big one, you can use a small one, but it doesn't have a value yet. To add a value, we can right click it and edit the properties, or I usually just press V for value, and then it shows up, and I'm like, oh, yo, let's give it 50K. It's a resistor, so that means 50K ohms. If you're feeling really fancy, you can put whatever you want in here. Sometimes I'll add the ohm. Can you put emojis in here? You can't put emojis in there, so don't do that. And then this top, like this reference, R2, you technically could rename that to whatever you want. I just really don't recommend it. It's like standard practice that all of your resistors are R, and they're all going to be numbered. So this is R1 and this is R2. And if you add 7,000 other resistors on there, they're all going to be R some other number. But don't change those, basically. And then you might be wondering, well, how do I connect things together? Well, on a schematic, we connect them with wires. And if you actually just click on the nodes at the end of them, they're just going to, by default, start drawing things around for you. Okay? You might be wondering about some of these components. So like a 3-volt 3 rail or a ground rail. Those are very useful to know. They're actually just other components. So we'll add them with A, and we'll search ground. And this is a power symbol. Okay? So they're always going to be in power. If you're not sure what it's called, I recommend searching for power, and it will just show you this entire like little folder of power symbols. So there's a 1v2, 1v5, 2v5, you know, everything that you could possibly want. Let's put a 5 volt. This is very common, okay? And you can wire it up. You can wire this one down to ground. Actually, since I already have a bunch of other grounds here, oftentimes I'll just grab one, Control C, Control V. That still works just like normal. But there's one more thing that I want to show y'all, and that is whenever we add components, let's add a jumper. You know, maybe you want to have a solder jumper because you want to give yourself some options to either open it after the design is done or close it after the design is done. And so we'll add this in here, and let's say, you know, I don't want it sideways in this schematic. Well, you can rotate it by pressing R, and that will rotate it. And if we press R and R and R and R and R, it will keep rotating it. And so you're going to be doing that a whole bunch. The other thing that you're going to be doing a whole bunch will be editing a symbol's properties. Well, we'll add an LED on the board. We'll put it here, and let's edit the properties. When you edit the properties, you'll get a little menu. And this is just kind of like a spreadsheet keeping up with all of the data that is inside of this symbol. And you can, this is really, a lot of it's just for you, you know, like it's called D1, its value is LED, but if we wanted to specify that this is a green LED, we could say green, its value is green. If you have a data sheet for a specific LED, you could paste it in here, especially with, you know, microcontrollers or different chips that might be doing things. You want to be putting your data sheets in there. It's so nice and helpful. You can put in manufacturing part numbers into there. All right, that's enough of that. Let's talk about one more thing that helps your schematics make a lot more sense. Okay? So let's talk about one more thing before we move to the layout that will help you mess around with your schematics. Let's talk about labels. Okay, so I'm just going to choose just a standard pin connector. Maybe we'll make it a socket, okay? And we'll put it up here. Let's say that this is a socket that you can plug into our board and it will power our board, okay? So what we'll do is we'll add our ground power symbol, okay? And then we'll add, and then we will add our 5 volt power symbol or whatever power is coming in. I'll align them, and now we're just gonna click on this to wire it up. Bing, bang, boom. Great. Press escape a couple times just to clean up the thing. Okay, so now we've done it. We made a socket, and if you plug in, it will connect to the board's 5 volt and connect to the ground. And now if I make another component over here, bring out my LED, and somewhere else on my board I have my component. I can connect this to the 5 volts, and I should put a resistor in between here. So we'll put resistor. See, I already want it small just because it's the space that I have. Okay, so I have my resistor. I want to set my values on my resistor, so I'm going to press V and set the value to 1 kilo ohm. And just like that, I've made a socket that you plug into the board, and it gives it 5 volts and ground. And I've made a component that takes 5 volts and ground and lights up. This is the LED. Maybe I'll set the value of the LED so that we know that whenever we're remembering to populate it and choose parts, we make sure to choose a yellow one because we like yellow or something. Cool. Okay. But let's say that, you know, maybe this isn't going to actually be a 5 volt rail, but it's actually going to be a signal coming in from an outside board. And whenever we want that outside board to be able to drive this pin high and turn on the LED, we could wire this just like this straight to our LED. And that's really cool. You know, that works. That totally works. But whenever you have a bunch of stuff, eventually you're going to have like wires going everywhere, and you're going to be like, wait, what is this one again? Is this the LED light? And you're going to have to follow it around. It's going to get really messy. So sometimes you're going to want to add labels on things. Okay, so what you can do is you can make a label, and we'll call it yellow signal. We'll call it the yellow signal, and we can just connect it anywhere that you see the square is where it is, and anywhere that you connect it to a wire, it will now be this whole green wire is now named the yellow signal because we've labeled it. And what's really cool is if we have another one of these, somewhere, or another place that we want this signal, we don't have to actually connect them. We can now just name another net yellow signal and now connect these two like together like that. And because they're named the same thing with the labels, they're actually going to be, it'll be the same as if we did that. Like, that's redundant now. So that's really, really useful, especially when you have like a microcontroller with like 50,000 pins. You'll just want to start naming things. And if you're naming something, you know, more important, you can also use the global labels. And they have a little flag around them, which is cool. Call it super yellow signal. Okay, and you can name that there. And that might, the purpose of why you would want the difference between a global label and a regular signal label, we'll get into on some other more complicated projects. But for now, I think that is enough. So let's move on to the layout. I think we've gone over enough schematic stuff, and I know that a lot of people are really wanting to get to the layout stuff because that's where all the pretty colors are. So let's just go ahead and scoot on over there. We're going to be focusing on this schematic. So we have a button, a resistor, an LED. Whenever you press the button, it connects it to ground, so it should light up. This is how we get our power and ground. They're coming in here, and they are properly labeled power and ground. And these power flags just specify where on the schematic the power is actually coming from, because, you know, it's not coming from the LED, it's coming from this part of the board, so that has differences. So what we do is we go up here and we click PCB editor. So whenever you get your schematic file, there'll just be nothing in it, and you'll have to come up here and press this pull the PCB file from the schematic. And whenever we do that, every component in our schematic that has a footprint will be plopped on over here, and it will put it all up in this top corner, and it will automatically like kind of have them placed. So I'm just going to get that off of the top corner. I'm going to bring it closer to the middle of our sheet, and I'm going to zoom in. Okay, and this is cool because we have our components. We can move them around by clicking and dragging them. We can, some of them, like this one is one that I made that's kind of big, and you have to grab it with the middle. You can drag them around by moving them. That's really cool. You might notice these light blue lines. That is called the rat's nest, and that tells you what your schematic has connected. So the wires on your schematic go to the pins on your parts, and the pins go to the nets. So if we hover over something, we press X, we'll start routing. And it highlights what to connect to. And it doesn't even let us connect to stuff that we can't connect to because it's not in our schematic. So that's how that works. And usually you'll use the rat's nest to decide how best to lay out some stuff so that you don't have to route so weirdly. So the first thing that you're going to want to do after you start routing some stuff up is undo what you've routed. And it's going to be really annoying because you're going to notice whenever you delete stuff, it only deletes like one little piece at a time, and it's going to be so annoying. And even as you highlight and highlight and highlight, let me show you something. If you press U, it will expand the selection. If you keep pressing it, it'll go all the way back to the pad, and then you can delete it. So that will save you a bunch of time. You'll route stuff, you'll select stuff, you'll press U, you'll delete it. Okay? Next, you're going to want to know that just like in the other editor, if you press R, you can rotate stuff. So that's really useful. Just like in the other editor as well, if you press E, it will open up the properties, but the properties of the footprint. Here you'll see the general properties, the clearance overrides, the 3D models that are connected to it, and any embedded files. The position might be really interesting to you. So let's do something, and let's first use what I just showed you there to place these components nicely. So I know that this is the edges. These are supposed to be on the edge of my circuit board. So what I'm going to do is press E, and since that little purple cross is in the middle, I'm going to put this straight up in the very middle of my file, which is at 100 and 150. Okay, and now it automatically moved it there. Next thing that we're going to notice about our board is there is no defined edge of the board, and it's just choosing the smallest bounding box that fits everything on it. And so now we're going to come over here into the appearance panel, and this is really important to understand that KiCad is just editing all of these layers. So we have the front copper, inner copper layers, the back copper, the silk screen, which are the white text on top of your circuit board, and then we get to edge cuts. Edge cuts is exactly what it sounds like. That's what we want to mess with. And so we have to make the outline of our board in edge cuts. And here's how I recommend doing this. Draw a rectangle And you're going to notice, I wish it was like CAD where you could like start from the center and move out. You can't really do that. But if you draw a rectangle and you're like, it's close enough, and you press E to edit the properties, now we can actually set things how we want. You can either set it by corners, if you want to do all of the math to figure out those corners, or by center and size like I want to do it. Because I know the center of my board is at 150 and 100. And I know that I want the board to be 35 millimeters by 35 millimeters. So I put that there, and here we go. Just like that, we have a square. Pressing Alt and 3 to show the 3D. Look, we made that. We made that square. Now, you know how to place components. You know how to place edge cuts. You even know how to hover over something and press X to start routing it. There's one more thing I'm going to show y'all. Oh, actually, two more things I'm going to show you is the draw filled zones and the place vias. Okay, so we'll start with zones. Zones are just like traces, except they're kind of like big shapes instead. So we'll start drawing. Oh, not on edge cuts. We'll go back to our copper layer, the front copper layer, and we will choose draw filled zones. And I will just start clicking. It'll immediately ask me, hey, what is this copper supposed to be connected to? Like you're basically making a new pad, and I need to know where it goes. So let's make it a ground, okay? And we can start drawing, and we're drawing a shape, and it's being filled in, and oh, we can even go way past the edges of the board, and you know, make whatever shape we want. Connect it back up, okay? And we're gonna be like, okay, that didn't do anything. Whenever we look at the 3D, it didn't do anything. So what's going on? The thing with zones is that you need to update them. It has to like render them, and you do that by pressing B. And that's going to fill them in. And you'll notice that stuff that's outside the board won't get filled in. It knows it's smart enough to do that. And now when we look at our board, we see that it filled in this giant copper. This is called a copper pour or copper fill. Now, the last button before I just call it a day for the video. We have this via. There are holes that go through the board, but they can carry connected wires through them, or they can carry signals through them. So if you place a via just out in the middle of nowhere, it's just going to connect to whatever it's on. So since we're putting it through the middle of this giant ground pour, it's connecting them to ground. And that's cool because now the grounds are connected. But it's also really cool because whenever we're routing things, like we don't need this one, but let's say that we're routing this one, and for some reason we can't get over here because I said so. If you start routing, you can use a via to travel to one of the other copper layers and then continue your journey there, okay? So let's get off of the top layer. Let's press V, and it'll immediately take us to the bottom layer. Oh, that's so cool, okay? And now we're like, oh, I can't connect. That's because you're on the bottom. You need to be back on the top. So press V again, come back up, emerge from below. Okay, and now let's look at this in 3D. We press B, and now we can see that our signal runs from this top layer all the way to here, goes to the via, travels through the via, through the board, and then emerges on the other side, continues its journey, goes back through via number 2, back up here, and then meets into the resistor. All right? And that is really neat. So what have we learned in my ramblings? Well, we know that we can open a project or create one. And we know that it comes with a schematic file and a PCB file. We know that we can go into the schematic file, we can move around, we can add stuff, we can change their values, we can generate a PCB file from there, we can move around in that PCB file, route layers, make a board outline, place components at where we want them to be with their position, and not only can we route traces, but we can also route vias and zone fills. So, all right, that's enough. You need to stop listening to YouTube videos and you need to go play around with KiCad, and in a little bit, maybe come back to our channel and maybe we've put out a more advanced KiCad tutorial. I want you to just build a project, something simple like this. If you're in the Discord challenge right now, I want you to just go play around with this, see what type of stuff you can make, try stuff out, ask questions, and we will answer them as best we can. Most importantly, I want you to just go out, have fun making stuff in KiCad, and yeah, see you next time.